Good morning.
Hey, Mr. Hunter, I have a question.
Yeah.
As far as the like the through calculus A to Z assignment you put on the Google Classroom, should we prioritize that now or still be focusing on this packet or the Taylor Polynomials packet and the like AP review, the limits, those other two documents that you put out first?
Well, you'll notice I moved the due date for the humongous review sheet to Friday the 24th.
Okay.
And the goal of that is just do that like over time. Like today, I'm going to hit major things from Unit 1 on that at the end. Like after we talk about Taylor polynomials today, we'll do a quick review of limits. And I'll touch on some things on that review sheet from Unit 1. Then I'll do some stuff on the review sheet from Units 2 and 3 next Wednesday. Some stuff from Units 4 and 5 on the review sheet from next Friday, and so on. So, I mean, if you already have the review sheet done, awesome. Or if you get it done well before the 24th, then cool. But I moved that so that the only things that you should do next week that have to be done next week would be the limits review and then the through calc A to Z.
Okay.
And because that big review sheet covers the whole year, I figured you needed more time for that.
Okay. So you'll want us to like turn in some sort of documentation of both of those two ones for limits and stuff being completed whenever they're in or due.
I mean, turn in something showing that you did it.
Okay.
Okay. And both those have due dates next Friday, and that'd be like by like 11:59 next Friday. And really, if you get it done after next Friday, if you wait till next weekend to do it, that's not going to be a problem.
So like if it's a few days back for the limit stuff behind that Friday due date or whatever.
Yeah, I mean, I'm going to have anything new that I ever give you, I'm going to have due dates on Fridays. But I mean, if things are turned in late, there's not going to be some late penalty.
Okay.
I mean, if you do everything late, you could get behind and not end up prepared for the AP exam. But if this time is weird, it's not perfect. This is not actual e-learning. This is not as if you were at a college class doing online e-learning. This is some weird hybrid that is not. No one.
Yeah, I get what you mean.
And I'll explain more when more people are on.
Good morning.
Good morning.
How was your weekend?
Wait, today's Wednesday, right?
Oh, sorry. How was
I
your
mean, I could still answer that, but just asking that made me think, was it Monday or was today Monday? It was good. Weekend was good. It has consistently been, it's weird doing church online. I don't know if you go to church or not. You may not. It doesn't really matter, but that's just something I do every Sunday. And now that's just really weird doing it online.
Okay.
But yeah, weekends. It's nice that we still have all this technology in this time. This
Yeah.
this whole situation would be a lot worse if the technology we currently have did not exist.
It'd be very difficult to stay informed.
Oh yeah, about stuff that was going on. I mean, just think like the 1918 through 1920 Spanish flu pandemic. I mean, that this current pandemic is not going to be that bad because of our current technology. Governments are more aware.
Yep.
And well, the medical industry is obviously way better than back then anyways. But I mean, if you lived during that time, you'd barely know what was going on. You wouldn't know there was a pandemic ravaging the world till like a month later, at least.
Yeah. Yeah, it's really nice to have technology right now.
Okay. Well, in today's lesson, we will finish Taylor polynomials, go over some kind of application problems, like the kind of questions you might see of not just make a Taylor polynomial, but they may ask you to do something with it. And then at the end of the lesson, start doing some review over a limit. All future lessons, we'll just be reviewing from here on after today. And so I'll hit some major things from each unit as well as in any future lesson. I've mentioned that YouTube channel before with the BC playlist of the AP review videos that they are doing. They are very good. In every single one of those review videos, starting next week, they will be going over free response questions, how to answer them, what they look like, that kind of thing. I highly suggest watching them again. Cannot reiterate it enough. The two guys doing those videos, they've graded the AP exams before. They don't have secret information about this year's other than what I've already told you, but they know what kind of questions could be asked. Oh my gosh, that was loud. That's loud. I'm gonna close my door right now. Okay. So, a few things I told AB earlier. You will get more information from district about this later this week, and then me more specifically, maybe later this week or next week. But starting next week, there will be grades. There will be grades for the 4th grading period starting next week. So anything we do starting next week from then on will be real grades for the 4th grading period for the rest of the year or until that changes somehow. They're constantly updating and changing things, but what I've been told is there will start being grades starting next week into the 4th grading period. And well, not like extra homework, like anything that I've already given you. I can tell you, it's not going to be tests. So it's just anything I assign on Google Classroom, those will be real grades, but all equally weighted as daily grades for the 4th grading period. Cannot have what's considered tests right now. No, not a grade for just being in the Zoom class, no. Because also, I mean, future Zoom lessons starting next week, part of it will be me reviewing major topics that we need to remember. And then other parts of it will be me like just doing a question answer and tutoring time over anything that I assign you. So the limit review, the through the Calc A to Z assignment, and then any other assignments or free response questions that we start doing throughout the next month, I will go over questions that you ask in the Zoom lessons from that stuff, or in the Zoom lessons, I'll go over questions from any of that I feel like we need to go over, or go over how, maybe go over how some of the free response questions will be graded, that kind of thing. But no, there wouldn't be a grade for just being in the Zoom class. Because also you don't have to all be in it. I record every single one of them. There was only one I forgot to. Now I have it set to automatically record. There's only one I forgot to record, but all the others will be recorded and posted. So if you can't make it to the Zoom lesson anyways, you can just watch it later. I would say for the 2 of you who are not taking the AP exam, you will need calculus in the future, most likely, or at least one math class. I know, Sean, you're probably planning on doing engineering, but you're not taking it. I would suggest to not make this year, so that this year wasn't a total waste, if you can, get into a summer session of Calculus 1 at Lone Star College this summer, then that would be a great way to at least be done with that before you start your freshman year. So just a suggestion. Okay, well, let's begin. Okay, we'll begin where we left off on Friday. No, not that. This. Not Friday, Monday. Every day feels weird now. I forget what day of the week it is a lot. Well, as I've said before during these lessons, it doesn't, just like during actual class, I would find it weird if you never spoke during the lesson. Feel free to unmute yourself and ask a question. As well as, since it's been stated before, when I'm doing the share screen option, I can't see your comments on the chat bar. So if you do have a question that you might want to ask in the chat, I can't see that when I'm sharing my screen. Okay, so just starting where we left off on Monday. This is the next page right here. So this says, actually, first, before we actually do those, let's remind ourselves what the Taylor polynomial and Maclaurin polynomial formulas look like. So the formulas. Taylor polynomial, it is a polynomial that will approximate the function's values near the function. So like e to the x or natural log or cosine or sine, those are the most common ones we use them for, or other weird functions. Those are not polynomials, but a polynomial would be like this: coefficient times x to the 0 power plus coefficient times x to the first power, and coefficient times x to the second power, and so on. And for it to accurately, or very closely accurately, approximate the value, it would need to have the same y value to actually be going through the point. Same slope, same concavity, and then same third derivative at the point, same fourth derivative at the point, and so on. So a Taylor polynomial, the different degrees of a Taylor polynomial tell you the power of the x value, as well as tell you what derivative, the highest derivative that's in it. So a first degree Taylor polynomial stops right there at the first derivative, and x is only to the first power. A second degree Taylor polynomial stops right there, where x is to the second power and it's to the second derivative, as well as you also divide by 2 factorial because it's a second degree Taylor polynomial. Then third degree then adds in this term with x is now to the third power, it's third derivative, dividing by 3 factorial. And this just generic Taylor polynomial is centered at C. Well, if we were centered at C, that's then called a Maclaurin polynomial. And if C is 0, then it would just look like that. And so keeping that in mind for this first problem. So they gave us a second degree Taylor polynomial. This is just the generic formula for it. We have second degree Taylor polynomial a plus bx plus cx squared, and we're told it's a second degree Taylor polynomial of this f function about x equals 0. Well, if it's about x equals 0, then that's really a Maclaurin polynomial. We're asked, what are the signs, meaning positive or negative, of a, b, and c if f is this graph? Okay. Well, the a, if we relate it to the formula for the Maclaurin polynomial, well, a is just a constant here. A is just a constant. Well, in the Maclaurin polynomial, f of 0 is just a constant. The b is the coefficient times x to the first power. In the Maclaurin polynomial, the coefficient times x to the first power is just f prime of 0. Meaning this is already telling us that a needs to equal f of 0. And that also makes sense. If the polynomial is supposed to approximate it, f of 0 needs to equal p of 0. And if we plug 0 into those x values, do we get a? Yes. So P of 0 does equal A, which needs to equal f of 0. And with similar mindset, P prime of x. Well, P prime of x would end up being B plus 2cx. And for it to be a good polynomial approximation, P prime of 0 would need to equal f prime of 0. And here, P prime of 0 would end up being B. If we go ahead and start looking at these, if this is our f function, f of 0 is just the y value at that point. Well then, f of 0, we just want to know, is a, b, and c positive or negative? Is a positive or negative right there? Since a is f of 0, well then is f of 0 positive or negative?
Positive.
Yeah, it would be positive. Okay, well, P prime of 0, the slope of the polynomial approximation at 0 needs to equal f prime of 0, which is the slope of the function at 0. Well, the slope of the function at 0 would be the slope of the tangent line. I could draw a tangent line. It could look something like that. So that B, slope of the tangent line, is that positive or negative?
Positive.
It is also positive. Okay, now let's look at the second derivative. Well, where did my green pen go? There it is. Well, P double prime of x would then just be 2c. Okay, and for it to be a good polynomial approximation, P double prime of x, no, of 0 needs to equal f double prime of 0, which equals 2c. Okay, and the second derivative of a polynomial or of any function tells us what about the function? What does the
Concavity.
second derivative tell us? It tells us concavity. What is the concavity of this function around x equals 0?
Concave down.
It's concave down, which means that c is negative because it's concave down. Okay. And the next one. We're asked, suppose that the function f of x is approximated near x equals 4. So that's the c here. We got this third degree Taylor polynomial. They just gave us the third degree Taylor polynomial. We're asked to find the value of f of 4, f prime of 4, f double prime of 4, f triple prime of 4. And so we want to relate this to the formula for a Taylor polynomial. Well, a third degree Taylor polynomial should look like f of, actually, let's go ahead and plug the 4's in for c. So it would look like f of 4 plus f prime of 4 times x minus 4. Only having those two terms, that's then a first degree Taylor polynomial. Then plus f double prime of 4 over 2 times x minus 4 squared plus, oh, I didn't leave myself much room, plus f triple prime of 4 over 3 factorial times x minus 4 cubed. Okay. So that's what the Taylor polynomial centered at 4 should look like, something like that. So that then tells us what some of these will be. We're asked what f of 4 is. So, well, f of 4 is just a constant in the Taylor polynomial. So what is f of 4 going to equal if this is our third degree Taylor polynomial? It's going to be equal to the thing that is just a constant. So 2. Then f prime of 4. It's the coefficient of the x minus 4 term. F prime of 4, the derivative at 4 is the coefficient of the x minus 4 term. Well, do we have a term that is just x minus 4? No. So then there is no f prime of 4 here in this polynomial at all. Which then tells us that f prime of 4 must be 0. F double prime of 4. Well, f double prime of 4 over 2 is the coefficient of the x minus 4 squared term. F double prime of 4 over 2 is the coefficient of the x minus 4 squared term. Meaning this negative 5, which is the coefficient of the x minus 4 squared term, must be equal to that coefficient f double prime of 4 over 2. Meaning f double prime of 4 over 2 equals negative 5. So f double prime of 4 must equal negative 10. And then process for the triple prime, third derivative of 4. Well, looking at the third derivative term, f triple prime of 4 over 3 factorial, coefficient of the x minus 4 cubed term. So we use that, and we will set that equal to the coefficient of the x minus 4 cubed term. So f triple prime of 4 over 3 factorial equals 8. Now we solve for f triple prime of 4. So we're going to multiply by, well, what is 3 factorial? 3 factorial is 6. So I'm multiplying by 6 on both sides. So f triple prime of 4 equals 48. Okay, then this is about the same thing. We're going to ask, does this f function, so f is the function that this third degree Taylor polynomial is approximating. We're asked, does f have a local max, a local min, or neither at x equals 4? Well, we figured out what the derivatives of f were. And so based on that, we want to know if we have a local max, local min, or neither at x equals 4. Well, we see here that f prime of 4 is 0. Well, if f prime of 4 is 0, that means we have a horizontal tangent, so we either have a max or a min. So since f prime of 4 equals 0, and f double prime of 4 equals negative 10, because these two things are happening, we can tell whether it's a local max or a min. If f prime of 4 is 0, that's a horizontal tangent. Then if double prime of 4 is negative 10, well, then what's the concavity?
Concave down.
It's then concave down. So we have a horizontal tangent and it's concave down. So by second derivative test, the local f of x has local max at x equals 4. If it's concave down and has a horizontal tangent, that would be a maximum. Looking kind of like that, concave down, x equals 4. Okay. And then I'm just going to do one, I'll just do part A on the next one. Skip part B. Okay, we are then asked, okay, we're told f as derivatives of all orders. They tell us f of 3 is negative 4, f prime of 3, 2, f double prime of 3, f triple prime of 3. We're asked just to write the third degree Taylor polynomial, centered at x equals 3. This is a very common type of thing. Doesn't require any memorization other than understanding what a Taylor polynomial is and its formula. So I'm actually, I'll give you a second, minute or two to do that problem, and then I'll go over it. You try to do that one on your own. I'm going to stop sharing real quick while I do it, and then show you in a second what it was. Okay, let's go back to sharing the screen and show you what it was. Okay, so the third degree Taylor polynomial centered at x equals 3 would look like, so I wrote p sub 3 of x, so for the third degree Taylor polynomial. Well, it's supposed to be f of c, so that's why I have the -4 right there, plus f prime of c times x minus c. That's where we get that term. Then plus f double prime of c over 2 factorial x minus c squared. So in that spot I have 3, 2 factorial is just 2, f double prime of 3, they told us was 7. And then plus f triple prime of c over 3 factorial x minus c cubed. So that's just using that formula and understanding what the formula looks like. Okay, next page.
And I know you said we're not doing it, but just for concept, if we were asked to do b, would you just be taking the derivative of that inside part, like for over and over for plugging in 0?
Yeah, you'd have to take the derivative of g 3 times, and you would use chain rule when you did that. But knowing the f values they gave you, you would be able to find that, because then every time you take the derivative, well, since we're still doing it about 0, when you plug 0 in, f just ends up being of 3. F, but then times something because of chain rule. Or it might be a little different. But yeah, you would just take the derivative 3 times and then make the same formula.
Okay.
Okay, on this page. Not sure if we'll get to all these. I want to save some time at the end to go over a few things about limits. Okay, so on this number 6, we're asked, we're told that when there's a function that had derivatives all work, we're told f of 0 is 5, f prime 0, f double prime 0, f triple prime of 0 is these values. We're asked to write the third degree Taylor Maclaurin polynomial. It's a Maclaurin because they have it centered at 0 for f, then approximate the integral from -1 to x of f of 2 dt. And again, these kind of questions that ask you to do both, write the polynomial and then do something with it. So notice, I mean, this is then testing, do you know what a Maclaurin polynomial is and how to write it? And then it's also testing, do you know how to do definite integration? So these are maybe the kind of questions you could see on a free response question as a way for them to test multiple different concepts within the same question. Because maybe they don't even ask you to write the Maclaurin polynomial. They may just ask you to approximate that integral. Well, you'd have to write the Maclaurin polynomial first, and then to be able to do that anyways. Yeah, so actually, to give you more practice, I'm gonna say right now, you take a minute and do it on your own. Then I'll show it on the screen. Try to treat this as much like class as possible. Okay, so we get okay, so continuing. So this is the polynomial approximation. 5 minus 3x plus 1/2 x squared plus 4 over 6x cubed. And that can be simplified to 2/3. So that's the Maclaurin polynomial approximation for f of t. We're asked to then approximate the integral from -1 to x of f of t dt. So I'll change it to with t's instead of x's then, so it looks like that. So then we now want to do the integral from -1 to x of 5 minus 3t plus 1/2 t squared plus 2/3 t cubed dt. Well, now it's just integrating, because we're doing a definite integral from -1 to x. So let's take the antiderivative. Antiderivative of 5 is 5t. That's t, not x here, because we're integrating with respect to t. The x will come into play when we plug in the upper limit during the fundamental theorem of calculus part. So we have 5t minus antiderivative of -3t. Well, power goes up 1, divide by the new power, so that'll be minus 3/2 t squared. Then plus t cubed over 6. Then plus 2t to the 4th over, okay, we're also going to divide by 4, and there's already a 3 there, so that'll then be over 12. And then that can simplify to 1 over 6. Bracket -1 to x. And next, we would plug in the x, and then subtract, plugging in the -1. So when we plug in x, that's then 5x minus 3/2 x squared plus x cubed over 6 plus x to the 4th over 6. Then minus, just plug in -1 into all that. And yes, that'd be a 5 times -1 minus 3/2. -1 squared will then be +1, so then that's just minus 3/2. -1 cubed will be -1, so then that's minus 1/6. And then -1 to the 4th will be a +1, so then that's plus 1/6. Okay, well those would cancel. We just have a -5 and a negative, oh, that should be 3/2. -5 and a -3/2, well, which is 1.5, so negative negative 6.5 is the f of negative 1. So then it would have minus 6.5, and that can just be changed to a positive. And then that would be our answer.
I got plus 6.5, I think. Did I put in a negative distribution wrong?
Plus 6.5 for plugging in the negative 1, or just for that whole term over here?
Well, I set for like minus, and then I just put in parentheses, plugging in all the stuff with negative 1. So inside the parentheses, you end up with negative 5 minus 3/2, but then you have to apply the negative of the subtraction and made it positive.
Wait, yeah, that's what I have over here. I put minus and then negative 6.5, then I, at the end, changed it to a plus.
Oh, okay. It's something on the screen or showing it was covering it. Okay, gotcha. Okay, yeah, that clears it up.
Okay. Can we see that better now? Okay. Then on the next one. It says let f be the function having all sorts of derivatives. We're told the 5th degree Maclaurin polynomial is this. So they gave us the 5th degree Maclaurin polynomial. We're then asked what is f prime 0, f triple prime 0, and then the 5th derivative at 0. Well, the first derivative at 0 is the coefficient of the x term. I mean, if we go back and look at the formula for Maclaurin polynomial, the first derivative at 0 is the coefficient of the term that just has x. The third derivative at 0 over 3 factorial is the coefficient of the x cubed term, and so on. So this f prime of 0, it's going to be the coefficient of the term that just has x. Put that on, that tells us f prime of 0 is 10. Then the third derivative at 0, well, it's going to be with the x cubed term. It's going to be with the x cubed term, but a little different. So the coefficient of x cubed is negative 4, and f triple prime of 0 over 3 factorial. That right there is the coefficient of the x cubed term. So that needs to equal the negative 4. Well, 3 factorial is 6, so we're just going to now multiply both sides by 6. And f triple prime of 0 is negative 24. And then similarly, the 5th derivative at 0. Well, it's going to be involved with the coefficient of the 5th power, x to the 5th power. So that 1/2 over here. And so the 5th derivative at 0 over what needs to equal 1/2? What should be in this denominator?
5 factorial.
Yeah, 5 factorial. Okay, now just one more step to figure out exactly what that is. 5 factorial is 120. So we're just going to now multiply both sides by 120. And that gives us the 5th derivative at 0 is 60. Okay. Okay, then number 8 asks, what's the coefficient of the x cubed term? Well, what should the coefficient of the x cubed term look like? Before even reading the rest of this, what's the coefficient of the x cubed term of the Taylor polynomial? Oh, well, actually, we skipped the function real quick. They said about x equals 0. If it's about x equals 0, what could they have called this?
Maclaurin.
A Maclaurin polynomial. So since it's about x equals 0, they could have called it a Maclaurin polynomial, because a Maclaurin polynomial is a Taylor polynomial about 0. So they want to know, what is the coefficient of the x cubed term? Well, on a Maclaurin polynomial, coefficient of the x cubed term is going to look like f triple prime of 0 over 3 factorial. That is the coefficient of the x cubed term. The x cubed term in the Taylor polynomial will have f triple prime of 0 over 3 factorial times x cubed. So 3 factorial is 6. You just need to figure out what f triple prime of 0 is for this function. Then just divide by 6. And I'll let you do that on your own. we'll go on to 9 and then be done for today. Well, no, then I'll do some limit review. Okay, on 9, so the function has derivatives of all orders about 0. So again, it's a Maclaurin polynomial. This is denoting the nth degree Taylor polynomial about x equals 0, known that f of 0 equals 8, piece of 1 of 3 equals 5, piece of 2 of 3 equals negative 11. We're asked what is the second derivative at 0. Okay, well, piece of 1 of 3, what does that even mean? Well, the subscript of the capital P represents the degree of the polynomial for the Taylor approximation, the degree of the polynomial. Well, if it says piece of 1 of 3, then that's a first degree Taylor polynomial, or first degree Maclaurin polynomial in this case. Well, p sub 1 of x, since it's a first degree, it will just have 2 terms up until x to the first power and up until the first derivative. And the first degree Taylor polynomial should look like f of 0 plus f prime of 0 times x. Well, they told us what f of 0 is, but we don't know what f prime of 0 is. If we continue looking, they then also have p sub 2 of 3 equals negative 11. Well, that will look very similar. I'll change colors for that. P sub 2 of x, the first 2 terms will be the same. F of 0 plus f prime of 0 x plus f double prime of 0 over 2 x squared. And we're asked to find f double prime of 0. So if we want f double prime of 0, we'll have to use this, but we'll need to know all other terms, meaning we need to know what, we need to have an x to plug in and what that would equal. We need to know f prime of 0 and f of 0. Well, they told us p sub 2 of 3 is negative 11. So that's the x value and function output that we can plug into this, but we need to first know what f prime of 0 is. We'll do that with this. Because we were told p sub 1 of 3 is 5, we can plug 3 into the x in this polynomial approximation, because this is a p first degree Taylor polynomial. This is the first degree polynomial at 3 equals 5. So we'll plug in 3 and get 5. We're told f of 0 is 8, so I got 8 plus f prime of 0 times 3 is supposed to equal 5. Now we just solve for f prime of 0. Okay, subtract 8, and I get negative 3 equals 3 f prime of 0. So f prime of 0 equals negative 1. Awesome. Now we know f prime of 0. We know f prime of 0. We know f of 0. We have an x in function value that we can plug in to be able to solve for f double prime of 0. So f of 0 is 8 plus f prime of 0 we just got was negative 1. The x that we are plugging in comes from this right here. P sub 2 of 3 equals negative 11. So we're going to plug 3 in, and the output should be negative 11. Plugging in 3 for that x, then plus f double prime of 0. That's what we don't know that we're trying to figure out. Over 2, then times 3 squared. Okay, now it's just solving for f double prime of 0. At this point, it's just some basic algebra. Okay, that right there, that's a negative 3. 8 and negative 3 makes this term 5. Plus 3 squared is 9, so plus 9 has f double prime of 0 equals negative 11. Let's now subtract the 5. That's the negative 16. Yeah, equals 9 has f double prime of 0. And then last step, just multiply by 2 over 9 times 2 over 9. And that would give us negative 32 over 9 equals f double prime 0. There's definitely other questions that they could ask regarding Taylor polynomials in regards to differentiation and integration. And you could be asked to find a Taylor polynomial, maybe just a second degree Taylor polynomial or third degree, where at some point to take the derivative, you have to use quotient rule or product rule, and then that tests if you know how to do those rules. Or they may give you an integration function for your function. So then finding the first derivative then tells them if you know how to do second fundamental theorem of calculus. And so there's many different things that they could add in, and you'll see that as we do some other free response questions later on. Okay, so that is it on that packet. Again, on next week, you can ask other questions about this packet if you have any, the homework questions. Right now, looking at the humongous review sheet. A few things from the limits on here that I want to go over and remind you of, especially for as well as on the limits, the other limits review. So as a reminder, the only way for a limit to exist and equal a finite value, the limit as x approaches a on the left would have to equal the limit as x approaches a on the right. So the left-hand, right-hand limit would have to equal the same finite value for the limit to exist at that point and equal that finite value. And so if we go and look at the limits review real quick on this graph, because the limit from the left and right have to equal the same thing. Does the limit exist? Like on number 2, what's the limit as x approaches 5 of f of x? Well, the limit from the left is 1 and the limit from the right is 3. So what would we call the limit?
Does not exist.
Yeah, does not exist. And does the function y value have to exist or the limit to exist?
No, it doesn't.
No, it does not. Because this limit review also does a lot of notes within it. And at the top, they do tell you, in non-math terms, that's what the graph is appearing to go in a certain direction, like whatever it's heading towards. Or as I said, or as it also says here, whatever the y value of that function is approaching, whatever it approaches. Something can approach something but never actually get there, and that would still be its limit. And so therefore, what would be the answer to number 1? Limit as x approaches 9 of f of x.
-1.
-1, yeah. And so f of 9 doesn't actually exist. We have an open hole, but the limit does exist because both sides are approaching -1. Okay, that was just a reminder of just a basic definition of a limit. Going back to the review sheet, few reminder on 6, 7, and 8. 6 asks about what does it mean for a function to be continuous at a point. So this right here is the 3-step definition of continuity. Continuity is a very common question from the limit unit that could appear on the AP exam. So for something to be continuous at x equals a, the f of a would have to exist. The limit as x approaches a of f of x would have to exist. And then those two things would have to equal each other. The limit as x approaches a of f of x would have to equal f of a. 3-step definition of continuity. And in regards to anything dealing with limits, horizontal and vertical asymptotes, continuity, if you're asked about discontinuities on a question, limit notation needs to be involved in what you do. Limit notation needs to be a part of your answer. And so therefore, we could talk about vertical and horizontal asymptotes without using limit notation, but the AP exam wants you to use limit notation to understand how a vertical asymptote relates to limits, such that if the limit as x approaches a of a function equals positive or negative infinity, like in this picture, the limit as x approaches 0 equals positive infinity on the left equals negative infinity on the right, I guess I should have had it equal the same thing, but then there would be a vertical asymptote there. And we also want to equate the idea that horizontal asymptotes happen as limits approach infinity. Horizontal asymptotes happen as the limit as x approaches infinity. If you go towards positive infinity on the as x goes towards positive infinity on the right, or as x goes negative infinity on the left, if those limits equal some positive or negative, if those limits equal some value that's not infinity, then that value is your horizontal asymptote. And then IVT, intermediate value theorem. It's not a very common question, but in case it is common, as a reminder of what, in case it does appear, this is what it is again, because you've definitely forgotten this. If a function is continuous on a to b, and you have some k, which is a y value between f of a and f of b, then there is at least one c, which is an x value between a and b, such that f of c would equal k. So it's essentially just saying if f is continuous on a interval, and you have some y value between f of a and f of b, the function has to go through that y value. There's for sure going to be one x value in the interval that's going to give you that y value because it's continuous, which more in layman's terms essentially just means if it's continuous, it's going to hit every y value between a and b. I mean, between f of a and f of b. That it's going to hit every y value and every x value at least once. Well, it wouldn't hit every x value more than once, but it would hit every y value at least once. Okay, and then one other thing that I talked about with AB earlier was average and instantaneous rate of change and the definition of derivative. So average rate of change, well, that is just f of b minus f of a over b minus a. And this is also called a difference quotient. And that gives you the slope of a secant line. Another way to write the average rate of change would be f of x plus h minus f of x all over h, where h is the difference, where h would represent the change in x, b minus a. So that is average rate of change, and using a difference quotient. Average rate of change and a difference quotient is often used to estimate a derivative. A very common question that I've seen many times is, given a table, estimate the derivative at a certain point. What estimates the f prime of 2? And maybe they give you f of 1 and f of 3, and you'd use those to get f prime of 2. So you can use average rate of change very close to the value to estimate the actual derivative. And if you take the average rate of change and throw limit notation in front, that gives you the instantaneous rate of change, which is definition of derivative. And that the actual definition of derivative limit notation is limit as h equals 0 f of x plus h minus f of x all over h. And then the alternate limit definition. Okay. Oh, and one other thing with limits. One other thing with limits. If we go back and look at the limits worksheet again. The most common form you will see limits. If you see graphical limits, it's most likely going to be like these, question 9 and not 1 through 8. 1 through 8 are way simpler than what you will probably see. Question 9 is more likely if it's a graphical limit question. But then let me go on. Okay, questions 23 to 27. 23 to 27 all use L'Hopital's rule. And as it says in this sentence right here, nearly all algebraic limits on the AP exam will be indeterminate, in which case you can use L'Hopital's rule. So yes, you can sometimes factor to be able to find the derivative. You can sometimes use in-behavior rules to be able, I mean, not derivative, to find the limit. You could sometimes use multiplying by the conjugate to rationalize. There's other methods we learned, but now that we know L'Hopital's rule, almost every algebraic limit that it asks you to do, can be done with L'Hopital's rule. Almost every single one of them. So know L'Hopital's rule and know it well. So L'Hopital, continuity, and just what a limit is and what a derivative is. Being able to find limits the other ways isn't as necessary, since we can do L'Hopital's rule. Okay. Awesome. It's only 4 till 2 now. So next, we're gonna not do, I already said that we won't have one this Friday because we wouldn't have school this Friday anyways. During review time, we're gonna not meet as much, only twice a week. So from now on, classes will only be on Wednesday and Friday. No more Monday class. No more Monday class. From now on, classes will only be on Wednesday and Friday. You can always email me questions. I will post as much keys and other resources online as possible. And starting next week, when we start doing review, we'll do some pre-response questions to prepare you. As another reminder, AP exam is now May 12th at 1 p.m. And
Are we going to be doing the same time for the Zoom lessons?
yeah, still every one of them will still be 1 p.m. They'll all still be 1 p.m.
The limits review sheet on Google Classroom doesn't have any problems on it.
What?
Like
Doesn't
it
have
has
any problems on it?
yeah, it has like the directions and then like below it's blank.
I know what he's talking about. It was kind of weird. I had to transfer to a Word document to see what was going on, and then when you print it, it's all fine and good.
Oh, when you print it, it works.
Okay,
Yeah,
then
it was
if
kinda
that's the
weird.
case, I'll upload a new version that's not a
That's
Google Doc.
ink.
I think Google Documents, it messed up the tables and it messed up the graphs and
Yeah.
equations.
Oh yeah, because they were in the form of tables. When I put it in Word, it was, yes, a certain format.
So I'll just upload a Word document instead of a Google Doc. I thought Google Doc might be easier, but I didn't realize that. Okay, so I'll change it and upload just the Word document instead of the Google Doc. That way you can see it all. I didn't know that.
Well, speaking of that worksheet, on number 9, where it has those limits and it has the two functions inside limit notation, did we split those by just using like?
So on those ones, you need to look at the limit from the left and the limit from the right. You would need to look at the limit from the left and the limit from the right. So it gives you those two different graphs. And like 9a asks for a limit as x approaches 3 of g of x times f of x minus 3. So you'd look at the limit as x approaches 3 from the left of everything inside that bracket, then look at the limit as x approaches 3 from the right of everything inside that bracket.
Yeah, so you don't need to split it or do anything like that.
No, you
It's
can't split it
direct
up because of the multiplication. But
on 9C, would they ask you to split it up because that's addition now?
well, you could, but it would still only work if they individually actually exist. You can't add something that doesn't exist to something that does.
Right.
So I would still suggest just figure out what the limit is from the left and the limit from the right. If the limit from the left equals the limit from the right, then that is your answer, whatever that value is.
Okay. And you said for Taylor polynomials, don't worry about Lagrange remainders or things like that?
No, you're not going to see Lagrange remainder. There's no way. Ratio test. Would it be helpful for me to post something that lists what section 10 topics could be on the AP exam and which ones will not be?
I guess so. I mean, there's a few, I don't know. It depends on how AP forms it, but I think a simpler, like watered down of what is like by topic instead of 10.3, 10.6, because we don't know so much what that means.
Well, I mean, if I only said, I wouldn't only say 10.3 or 10.6. I'd say
The
the topic as
specifics.
well. I'll post something that says which sequences and series topics are on the AP exam and which ones are not. I'll post that just as an announcement in the Google Classroom. And I'll re-upload the limits worksheet. I didn't. The equation editor and tables turned out weird in Google Docs, I guess. Nadine, for all classes, it's just going to be all equally weighted grades. That is what I have been told so far, yes. That any grades that we do starting next week will all be nothing is going into the assessment or major grade category. They're all supposed to be daily grades. Every teacher should be doing this. This is what I heard from administration both on Monday and today. So all grades. I mean, I don't. That could change when we come back to if and when we come back to school. If we really do come back to school May 4th, maybe the last 2 or 3 weeks are different and more normal. But definitely for the next 3 weeks, when we for sure are still not in school, all grades will be weighted equally. And Qual added in the chat which ones are. Did he? Oh yeah. So as Qual put in the chat, all of section 9 is not on it. Then he has certain ones that he listed that are not. What convergent and divergent series are, nth term test, integral comparison tests, absolute convergence, and some other ones are not. I did go over some of those things because there's no way we could have understood some later stuff without understanding just what convergent and divergent series were. And nth term test is an extremely easy test, so why not go over it? So there was a few things that I did go over that are not on the exam. But then he also wrote down, Qual also added in the 5 topics that are. Working with geometric, harmonic series, and P-series are on the exam, alternating series, ratio test, and finding Taylor polynomial approximations using functions, which is why we didn't go anything past being able to write and use Taylor polynomials. Sean, if you mean anything for the past few weeks being used for a grade, that is not going to happen. For your 4th grading period grade, nothing from the past few weeks, based on my understanding, can be used. It seems like technically 4th grading period is starting next week. Anything we do, Zeus, anything we do in Google Classroom will be for a real grade. But as I was, most people weren't in the class yet. Isaac was asking me earlier, like about the deadlines and what he should be worried about working on right now. All of my deadlines, if you are taking the AP exam, which is all but 2 of you, you should for sure do everything I assign for practice to be able to prepare. Because another thing to remember, please everyone remember this, because this will make you want to do the work, is this year's AP exam open notes? Someone answer. Is the exam open notes? Yes, it is. So you should want to do all the work. You could have this giant review sheet next to you during the AP exam. And so you should want to do all the work. And so you'll get it done at some point. But also, I'm going to have almost every assignment that we do on a Friday. If at some point you don't get something, you'd work on it the following weekend, that is completely okay. Due dates are more like guidelines, but you should want to get everything done before the exam as for sufficient practice. Like you're not going to get any points off during this time for things being late. That's for sure. There's nothing there's no such thing as late points off during this next grading period. So, I mean, if you wait a while to do some of the assignments, that is okay. If you wait till after people ask me questions on the Zoom lessons to go ahead to just get the answers from me, and that is okay. Just like usual, I'm going to post the keys to almost everything that we do at the calendar. So
That includes the AP, or not the Google Classroom stuff.
Google Classroom is where I'll post like the blank assignments to do, but the keys will still be found same place as usual at the calendar. Keys will still be at the calendar.
And then if we just took a picture of like whatever we did and just submitted that, you said that's fine, proof of just doing it.
Yeah. Well, and I mean, practice being able to do that as well, since that's pretty much what this year's AP exam is. Just working on your own piece of paper, then taking a picture and uploading it. And as a reminder, I mean, something that's not going to be for a grade, but highly suggested for all of you taking the AP exam is the AP Classroom personal progress checks. Some people in AB have already started working on them. The AP Classroom personal progress checks, don't worry about doing any of the multiple choice ones because there's no multiple choice this year. But the free response question personal progress checks are a great practice for this year's AP exam, especially any of the ones that cover multiple units. Any of the ones that cover multiple units in that free response question, you should do. And once you submit it, it'll automatically come to me. I'll score it so that you see how you do, but it won't be a grade for the Langham Creek grade book, but then you'll see how you did. And then, I mean, you could print it off and have it next to you during the AP exam as reference if you wanted to. Yeah. Any other questions before we end?
Are we gonna take a practice like FRQ AP exam as a class, like online?
Speaking of that, let's go look at the calendar real quick. I'm going to share my screen again. So, there we go, BC. So this right here is next week, amongst review sheet, AP limits review, journey to calc A to Z. That's the only things you should really worry about doing that week. Notice the following week of April 20th. On Monday, it says 2016 FRQs. So I'll probably send that out to you maybe sometime next week. So you could start early if you wanted to. You could start it next weekend if you wanted to. So yes, we will do FRQs. These ones are the actual FRQs from 2016 that we'll do. And then also that week, a guy named Brian Password, the same guy who has been doing the YouTube live videos for Calc BC. He made some FRQs that are what he thinks this year's could be like. And so we'll also do those ones that week. Master Math Mentor, the place we get all of our notes and homework. Stu Schwartz made FRQs that he thinks this year's will be like. And so we'll do those the week of the 27th, and I'll find just one or two FRQ questions over some other topics I think we need to cover. Week of the 4th, we'll do the 2018 FRQs. And then one final review sheet. So we will do a lot of free response questions, some from actual previous years, some from people who wrote new ones this year based on what they think this year's exam might be like.
So the way that'll work is like looking at what's on there right now, like you would assign, quote unquote, or whatever, the 2016 FRQs, and we would go over them on the 22nd for Wednesday class, and then the Passwater FRQs for Friday class.
Yeah, probably. It's probably what's going to happen.
Okay, got it.
Yeah.
I'll probably send out the 2016 FRQs next Wednesday. And then we'll go over it during the Zoom lesson, the Wednesday of the 22nd. And then I'll probably send out the Passwater FRQs maybe on the 20th. and then we'll go over it that Friday. I'll try to give you as much time as possible to be able to do them, as well as and when I send out that assignment, I'll also mention how long those particular FRQs should take, or there are certain ones that you may not have to do. I mean, since Unit 9 is not on this year's exam, there's probably one whole FRQ on the 2016 FRQs that is dealing with parametric and vector equations, and well, then I'd say you don't have to do that question because it's not, that topic's not on this year's exam. So, but since Passwater and Stu Schwartz of Master Math Mentor, they made ones of what they think this year's will be like, that won't be the case with those ones, because they took out any of those concepts. Any other questions before we end? Okay, well, it's been a long lesson so far, so have a great day and a great weekend.
It's Wednesday.
It is
We're
Wednesday,
not having
but
class
we're not
Friday.
going to meet Friday.
Oh, what?
Friday we would have off anyways if we were in school.
Okay. Bye.
Bye.
Have a good weekend.
You too.